Good morning or good afternoon, depending on where you are today, and thank you for joining us. My name is Lisa Geary, and I am the Product Manager of Dental Solutions here at Roland DGA, DGSHAPE Americas. Today we're excited and we're eager to talk about the newest addition to our Roland DGA, DGSHAPE Americas dental product line. The new C-clamp adapter is now available exclusively for our DWX-52D dental dry mill. Before we get started, we do ask that you save any questions that you might have for the end of the presentation, as we will have a live Q&A session. So let's get started. The C-clamp adapter allots for improved milling range and design. It expands the function of the DWX-52D dry mill with a 90-degree milling range expansion versus our standard material adapter. This provides for greater overall milling range and aesthetics. In addition, it allows for milling of those larger full arch cases where the offset may interfere with the standard material adapter. So how does the C-clamp adapter work with the DWX-52D? You start by removing the adapter cap from the C-clamp, then set and secure the material disc into the C-clamp base, then secure the adapter cap back onto the C-clamp with the mounting screws, and finally place the C-clamp adapter into your DWX-52D and you are ready to mill. The C-clamp adapter is compatible exclusively with the DGSHAPE DWX-52D and supported by both Mailbox and Hyperdent CAM software. The C-clamp is a Roland DGA SKU number ZMA2-52D and has an MSRP of $430.95. It is available for purchase exclusively through an authorized Roland DGA reseller or online at rolanddga.com/dental. And now I'm going to turn it over to Michael Webb of Sim System USA, who is here today to provide us some helpful tips for use of the C-clamp adapter with Mailbox CAM software. Mike.
Hey there. Good morning and good afternoon to you guys, and thank you guys for joining us. Lisa, thanks for the introduction as well. What I'm going to go ahead and do is talk to you guys today about the C-clamp functionality as it exists within Mailbox, show you how that works in the CAM and how that translates onto the machine as well. So in order to do that, I'm just going to go ahead and share my screen. And that's going to allow us to see exactly what I'm doing on the computer and how that's going to play into your workflow. So here we can see I've already gotten the C-clamp adapter pulled up and imported on my 52D. So this is what that new C-clamp fixture is going to look like to you. And we're going to go through a couple of use case scenarios, not only just showing you how the workflow works within Mailbox, but showing you actual practical usage of the C-clamp as it exists in the lab. So I'm going to start from the top, which generally kind of helps people understand where that new C-clamp selection comes into play. So in Mailbox, when we're selecting our machine, we also go in and select the clamp or the fixture that we're going to be utilizing. Now, this is going to vary based on the material that you're utilizing. But basically, I'm selecting zirconia for this. That's typically where we're going to use the C-clamp most of the time, but it really depends on your lab and your workflow, because in some cases you may be wanting to utilize the C-clamp in PMMA, which is also a very popular material to be using it in. So let me switch over to the C-clamp fixture here, and that's all we have to do. So one of the prerequisites to be able to see the C-clamp in your Mailbox version is there's two things. You need to make sure that your annual maintenance is covered up to at least Mailbox 2020. We're now in 2021, so if you're updating already, you're updating your annual maintenance, my suggestion is just go ahead and go with the latest. That also gets you access to any type of bug fixes or anything like that that comes up along the way, but also improvements that we end up making to this down the line, since you can only access these updates when you're on current maintenance. So in this particular example, if you're not sure what version you have of Mailbox, usually it will tell you in this top right-hand corner. It's also possible that you may not have that up there. It may not show the 2020. So one way you can also get to that is by right-clicking the top menu bar and then going down and clicking on support. And so right now I'm on a temporary license, but if you're using a dongle and you're operating off of a USB key, you're going to see your 4 or 5 digit dongle number here. And in parentheses to the right of that is going to show you what version your dongle is capable of running. And then up top above that, you can see the Mailbox version here showing me that I'm running a 2020 revision. And so I'm using a slightly newer version than the one that's public, but in terms of availability to people that are using version 620, which is actually released on our website, you'll have access to that. So if nobody's ever been to our support website, it's an easy link. It's support.simsystemusa.com, and that's going to get you to our web portal here. And then if you scroll down under downloads, Mailbox downloads, you're going to see Mailbox DGSHAPE edition versions 6.2.0. And in here, we have a little bit of information about what is required with that installer. But if we scroll down, we have the download links for that, as well as the release notes. And if we look at the release notes, we have all the important changes that we've been making to the software down here on page 2, because we actually released the C-clamp in the software back in November of 2020, just to kind of be ready for it when it did hit the market. So that is how you can ensure to get access to be able to see this icon right here. And once that icon is available, now we can go in and select it and utilize it for our workflow. So we've selected our fixture, our material, and now what we're going to do is go in and select some cases to mill out. So in this particular example, I've got a couple of different STL files in my archive. So we're going to use, I'm going to start with the full contour crown, just to show the general capability of it. And the reason I'm doing that is just to kind of give you a good example of one single case that we could use it in. Now, we wouldn't typically use the C-clamp to our advantage on a standard crown and bridge case, because there's really no undercuts that prevent a limitation from a milling perspective for us to get in there. It's really when we have cases that have a lot of undercuts or have some very tricky undercuts. And you can see in this case, this with this facial cutback on this molar, we have some pretty steep angles. So even if we enabled 5-axis and we're using a standard clamp or fixture, we would really have to hog out a ton of material around this part to allow clearance for that tool to get in there and mill out these sharp edges. So that's really where the C-clamp comes into play and really kind of shines. So I'm going to import this full contour crown. After it's done importing, my next step is essentially going to be that I'm going to want to orientate this crown in the job. So let's do that here real quick. Now, initially, it's going to show the crown upside down. Now, this is a default behavior to Mailbox, so it's nothing uncommon, nothing to be alarmed about. We prefer to show you the prep line or margin because we want to validate that the margin line is detected correctly. So I can hit my F9 key and everything will kind of go right side back up, and that allows me to continue forward in my workflow. So here my crown is 10.36 millimeters in height, which means that I'm going to need to select a larger disc for this case. I'm going to go ahead and create a 12 millimeter disc. We're just going to call this one Mike, and I'm just going to create a fictional lot code here for this example. All right. And then once our disk is imported, this is where we can now open up the offset for a particular part. So that's going to be our very first step. What I'll probably want to do also, because it automatically generated a support pin on the facial of this part. So I'm just going to select that support pin and hit delete on my keyboard, and that just removes it because it's in the way right now, and it will be once we open up the offset border. So my first step really is to orientate the part with the edge of the disk as much as possible. Now, if you can't put it right here in the center, that's fine. I can move it toward the top or toward the bottom. But generally speaking, it's best to try and center your parts up, especially if it's the first one you're opening up the border on. And because we've nested our part slightly outside of the part border, it shows up as yellow. That's completely fine. But when you start to get too close to the edge of the machinable area, you'll see that it highlights this area in amber. And that's kind of like a little warning, like, hey, you're getting to the edge of your machinable material. If you take it out, it actually turns red. So we want to kind of we want to split the difference there and get close, but not too far close to the edge of the disc. And this also depends on the material, because some material have a smaller machinable surface. Like if you're using materials that use those plastic rings that go along for the collar, like a katana material or something along those lines, I believe the machinable surface on those is 95 millimeters as opposed to 98. So take that into account when you're placing your parts here. So once I've placed my part here, the next step is to open up my offset border. And that essentially gives me the option to come in here and move these green balls anywhere I need. If you didn't catch what I was doing there, essentially all I had to do was select the part and then click on the tool above it. So in this case, I've placed my parts where I need them to go, and I hit the check mark. Now it's asking, do I want to select the parts to be milled along that open side? At this point, it's more or less asking from an automation perspective. Mailbox can automatically go in and detect the areas that need to be milled on the facial surface and subsequently mill those areas. Otherwise, I could go in and select that I don't want it to automatically mill it, and I could designate that manually. So I'll do it automatically for this particular case, and then I'm about to do a bridge as well and show you that workflow. And then we'll take the opportunity to paint it manually in that case. So we got out of that option, and essentially now all I'm doing is just kind of arranging my support pins to support this part as it's going to be milled out. Now, if I wanted to, because I'm only holding on to it with 2 support pins, if I wanted to beef this up a little bit, maybe give it a little bit more strength to hold it in the machine, I can select those and come in and just make them slightly larger. And that's going to kind of compensate for the loss of that other support pin that we would typically have on the facial or somewhere else on the crown on the opposite side. So you can see that opening my part border was very easy. Essentially at this point, because I've told it that I automatically want it to go in and mill those surfaces, the CAM software, when I go to calculate this, is just going to open those surfaces up and mill them. Now, alternatively, I can still use additional steps for the machining process. So let's say that, for example, I want to utilize my 5-axis undercut milling for those sensitive areas as well. Well, if you don't want to use the specific 90-degree toolpath, we can do that. So during the calculation process or during the strategy selection process, we'll get a pop-up, and that pop-up will indicate to us the various different types of machining steps that we can take in order to mill this part out. So I just reinstalled my CAM, so it's going to take a second for that window to pop up that first initial time. So we'll give it a second, and while it's doing that, I'll open up another instance and we can look at the bridge case. Or, well, here we go. It actually pulled up here in time. So we can see here, we have a couple of different options for how we want to mill out this part. So I mentioned we could do it with the standard external undercuts. We could either do it in 3+2, which is essentially indexed machining. Let me minimize that back. So 3+2 is index machining. It utilizes all 5 axes of the machine, but not simultaneously. And that's very important to understand, because indexed is essentially going to tilt the part to the axis needed where the undercuts are exposed to the spindle. And then we're going to come in and mill those undercuts, but everything is indexed. So essentially your rotation axes are not moving, they're locked. And then you only have the X, Y, Z. And then we're going to tilt it forward 15 degrees and do the same. Tilt it to the side 15 degrees and to the other side 15 degrees. So that's kind of how the 3+2 works. A 5-axis simultaneous toolpath, if there's undercuts on the front, it's going to tilt it up, but it's going to keep those rotation axes engaged. So in some cases that can actually net you with it's a faster runtime, but sometimes that can net you with a little bit better exposure to those undercut areas, as the 3+2 is more static. And so with the 3+2, because it's tilting it along known axes, in a way, you also want to orient your part along the X and the Y axes, or the undercuts that you have along those axes as well, versus the 5-axis that will just come in and mill it wherever. Now, the special machining 90-degree, this is essentially where we take that open face of the disc. So if we're looking at my hand here, this is the open face along this side, and we're going to rotate the disc upward. So that way the spindle is looking straight down at that open edge of the material. And we're going to mill all that material away. And there's a couple different options that we have here. So I can mill all the surfaces with the 1mm tool. Now this is that automatic function where I didn't have to paint any of those surfaces. And that's what it was referring to, like, hey, do you want to paint those surfaces when I opened up the border? Because I said no, we'll want to make sure that we always select this. If I had said yes, and I did want to go in and paint those surfaces, which I'll show you on a bridge, these are one of the 3 options that I would select. And I can choose to do it with only the 1mm tool. I can use it with the 1 and the 0.6, or I can do it with the 1 and the 0.3. So this is going to allow me to get not only the details that we could get with a 1mm, but I can get those smaller tools that are typically only reserved for the anatomy, and I can get those into those facial aspects of the part, whether that is an embrasure or whether it's a portion of the emergence profile, like if you're doing a full screw retained bridge or something along those lines. So now that I'm done selecting that, all I have to do is hit the check mark and continue forward with my calculation. Now, due to our limited time and to be able to show you guys as much information as possible, I'm not going to go through a calculation and make you guys wait for that. And also, in the interest of time, I've gone ahead and imported a screw retained bridge and kind of pre-nested it because essentially we're showing you guys what you can do different today, right? So I don't want to have to go through the entire workflow and make you guys sit through that. So here we can see I have a bridge, a screw retained bridge, which is maybe like an all-on-4 type case here. But you can see there's a lot of undercuts here along the facial surface, especially as we get closer to those embrasures, some really deep undercuts there. So in this particular example, what I'm going to go ahead and do is open up the offset border again. So if you missed out how we did that last time, we're going to start out by selecting the part that you want to open the offset on. We're going to move the part over and get it as far out of the disc as possible. Now, due to the shape or curvature to this particular arch, I'm kind of limited to how much facial detail I can get because the C-clamp only opens up so much. So, there's some physical limitations to take into account as you're doing your designs. But I could choose, and this is not an all or nothing type thing, right? So if I can't achieve what I need to with the open face C-clamp, there are other options like increasing that offset to create that additional clearance for those tools to get in there. So you're not left having to choose between one or the other, right? Okay, so next up, I'm going to grab these green balls, and I'm just going to, again, this controls where the cutting operation occurs. So we always want to make sure that we don't get anywhere close to the edge of that C-clamp. It's not going to mill on it or anything like that, but the machine or the cam will give you a bunch of error messages when you go to calculate if your part border or your offset around your part actually interrupts or interferes with the fixture itself. So luckily there's some built-in intelligence to mitigate or prevent that, but you definitely want to make sure you get it right from the get-go. Okay, so in addition to moving those balls to control where that opening of the offset occurs, I also have this slider, which I didn't show you on the last one, but I'll show you right here. So as I drag this slider, it affects the draft angle at which we're actually going to cut along where those green balls have been placed. So we're going to want to ensure that we have an adequate draft angle depending on your part. And really on a bridge like this, you're always going to want to go and take as much material away as you can, just to, additional clearance is additional clearance, right? But if it's like a single unit like I was working with before, I might have actually finagled that because as you saw, that was a very small unit and I really opened up all the way around the side. Now, if you have cutbacks on embrasures, or excuse me, cutbacks on your interproximal areas, you're definitely probably going to have to increase that draft angle as much as possible because the tool is also going to be coming in from this direction. So that's something you want to take into consideration. You want to make sure that it will still be able to mill those surfaces. So again, it's asking me, do I want to select the areas to be milled on the open side? I'm going to say yes, I do want to select those areas. And that essentially brings me into my paintbrush tool. So there's two options there's a couple different options that I can do here, but essentially at this point, all I would need to do for the 90-degree operation is simply come in here and paint my surfaces. And so what I'm doing is clicking and dragging. You can kind of drag and rotate the part as you're painting the surface. What you want to avoid is, if you're doing a single click to paint the surfaces, that's fine. What you do want to avoid is doing anything like, say, this right here, because the toolpath that's going to be rendered for this operation is what we call a zigzag toolpath. So all the green areas the toolpath can see. The white areas or the blue areas, it's not necessarily going to touch, only those areas that we painted. So if we create a small little gap right here, we have to think about how the toolpath is going to be executed. So zigzag means it's going back and forth, up and down along this green surface. Once it touches this spot right here, it sees that it has another green spot above it, but because there's white area from the STL that wasn't designated, we've essentially told the cam for this toolpath, you can't mill those areas. So the tool would actually have to jump up and then come back over, then re-engage with your part or with the material, which means that anytime the tool is not touching the material, it's wasting time, right? So if we did have an area where we had undercuts up closer to a cuss tip or something like that, then I'm gonna want to make sure that this is kind of one contiguous painting. I wanna make sure it's connected as much as possible, if that makes sense, okay? So we're just gonna undo some of those steps to get rid of that. And then I'm just going to kind of continue painting along my surface. Now, something else you can do if you don't like the paint tool or it's not fast enough for you, you can use this paint bucket tool. And if you zoom in, the radius gets a little bit smaller. So you have a little bit more granular control over what you're trying to paint. But let's say that we wanted to kind of select that area because now I have that paint bucket selected. We can just kind of draw a perimeter and Mailbox will automatically come in and fill in those spots or zones. And so when you see some small areas like this, you may want to go ahead and shade those in as well, just to make sure that the cam was able to see them. But there's going to be some slight tolerance differences there. So as long as you've got the green area over those embrasures and through them, I'd say you're going to be fine and the toolpath is going to do what it's designed to do. And that's why I said we had two different options for how we could play out and how we're going to handle that 90-degree operation. So there are of course other cases, use cases that you can use for the 90-degree milling operation. One of which could be like if you have a part that is a little bit too tall maybe to fit in the disc that you have, you can lean that part on its side and actually come in and mill those zones. Now this is kind of more of those very situationally specific cases, but essentially it does require a little bit of assistance from your dealer because they have to go in and turn off the axes limitations on your machines. Because obviously if we flip a part on its side, the cam is going to be like, oh, well, it's outside the machine's limitation. So we essentially turn those limitations off, and that allows us to accomplish tool paths where we can kind of essentially kind of change the orientation of how the job is milling out almost entirely, which is really nice. So I hope that was a good explanation for you guys. I hope it made sense for everybody. If you do have questions on this about how to utilize the C-clamp, we do have help documents on our webpage. So if you go to again, it's support.simsystemusa.com. It's going to bring you to this main page, and there's all kinds of frequently asked questions about Mailbox, and then help videos that kind of walk you through the workflow, including information that we're going to be posting about the C-clamp. And then of course that Mailbox download area. So this is going to be the most important one. If you don't have a current version or if you're behind, you can check with your dealer first, make sure that they have a version that's available with the C-clamp in their own installer. And if they don't, and you're using a DGSHAPE version of the cam, you can go to our website and obtain this, or you can work with your dealer and they can install the DGSHAPE edition version on your computer. And that would be actually separate from your dealer's version. So you can work in tandem with it, or you can, if you decide you want to use the latest and greatest, you can use the DGSHAPE edition, whichever works best for you guys. So, and yeah, that's it. So back to you, Lisa. Thank you.
Perfect. Thank you so much, Mike, and thank you everyone for joining us today. Now we're going to open it up for a live Q&A. So please, if you have any questions, please be sure to put that into the chat, and we're happy to answer any questions that we have. As far as any service or support related issues, we do ask that you do visit rolandga.com/support. We have a question of whether or not the C-clamp is going to be available in the Latin American region, and whether or not that's going to be part of the DGSHAPE edition or the Mailbox LAV edition. Do you want to answer that, Mike?
Yeah, that's a great question. So it will be available for the LAV version. We're actually working on putting out the Legacy 2020 build for LAV, and that is going to be one of those features. So the way that you can think about it with the LAV, or those, because we do have some reduced versions of the cam that get sold with the machine. In the South American market, this is one of those particular instances. So in those instances, any eco version that we have, if it's a capability of the machine, we will always kind of put that in there as something that those eco versions will get. So the eco versions of Mailbox, the only restriction really is what type of objects you can mill, not necessarily the applications that you can use to mill. So hope that makes sense, but the answer is yes. Short answer is yes.
Perfect. And do we have any other questions? The next question says, can we use this on a DCI? Unfortunately not. The C-clamp is only available for the 52D model with the automatic dish changer. Unfortunately, the C-clamp is not compatible. And it looks like we've got a couple more minutes and a few more questions coming through. Do you have anything else, Mike, that you might want to briefly go over? Maybe a little tidbit about nesting with Mailbox that we didn't think about? I think you're muted, Mike.
Yes. Yes. Thank you. Yeah, we can certainly go into some other potential applications here. Let me just share my screen.
Just a few more minutes, so we might as well utilize it.
Absolutely. Let's switch over to the right camera here. Okay, you can see everything now. Okay, perfect. So there were some other potential options depending on what type of a case it is that you're working on. You know, we talked about, now I didn't show it on this particular machine because the sample case that I ended up getting was a little bit too steep of an angle for the fixture that we have available. But let me show you another potential use for that. So on surgical guides, you know, we kind of talked about a single unit, and then we also talked about a screw tane bridge. But as you can see, this is a surgical guide that, for all intents and purposes, you wouldn't be able to mill at all on any machine, just because of all the complex shapes. And usually this is going to be a limitation on the axes of all your mills. So at least these portions on the facial where the guide is going to be drilled from. So this would be a perfect case scenario if you have a C-clamp that is open wide enough, or a case that you have holes that need to be drilled from the facial side, that you can also kind of nest those in there and provide the clearance that the machine needs to come in and mill those particular areas out as well. So that was the other case scenario that I think that you could probably use this in. And I'm sure there may be some other examples that I might not be thinking about. So, you know, don't think that these are the only applications that you can use them. I'm sure there's others that some of our advanced users may run into as well. So.
Absolutely. It looks like we do have one more question.
Okay.
It says, is it doing the 5-axis when the 90-degree milling stage, or just the 3+2? Do you want to answer that?
No, that's a superb question. So as it relates to what axes are being utilized, there's two different types that we can mill it out. So we could mill it with a 5-axis continuous toolpath, which is the same as what you use today. But because we've now opened up that facial surface, that 5-axis toolpath will be able to really get in there and mill those facial surfaces out. So that's one way you could go about it. The other way is utilizing the painted surfaces or those 90-degree options that are down below. And so essentially what that does is it will orient the part upward. So let me go to my my other screen here and I'll show you. We'll switch over and share it. There we go. So essentially, imagine we're looking from the perspective of the spindle. So it's going to come in and do that zigzag toolpath running from left to right. Not only is it going to do that with the B-axis locked, we're actually going to unlock the A-axis in its rotation. So as we're milling, we're going to tilt it slightly forward toward the front of the machine. Then we're going to start milling on the left side of the bridge. And as we proceed along that bridge, you're actually going to see one of the tilting axes rotate along with the part. And so that allows us to keep the tool kind of perpendicular to the surface there and allows that radius to really get into those surfaces. And so you can really achieve nice parts coming off the machine, you know, with little to no handwork necessary. So that's a really good question. So in that example, we're not actually using 5-axis simultaneous because we're doing the 4th axis in simultaneous, and then the other rotation axis is locked, and then we have the XYZ unlocked as well. So hopefully that makes sense, and maybe kind of learned a new use for that 4th axis.
Perfect. Well, it looks like we're just about out of time today, Mike.
Sure.
So we just want to thank everyone again for their time today. If you have any questions, please feel free to contact us. For support-related issues, rollandga.com/support. And then, Mike, do you want to go ahead and give the SimSystem support site again?
Yes, our support site is support.cimsystemusa.com. Thank you.
Perfect, and thank you all again, and have a great day.